Welcome to Blockchain Ardor. This is a special edition. I'm Crypto Demetrius, and in this installment, you're in for a real treat. A full 25-minute seminar on the revolutionary Turing-complete lightweight contracts that were recently released on Ardor's testnet. This seminar is led by lead developer and managing director of Gellerita, Lior Yaffe, and it was filmed by Elizabeth Mong, the executive director of Ardor NXT Group, during the Danube Game Jam's Ardor Hackathon in August 2018. This is a lengthy video, so take advantage of the timestamps and resources in the video description below to help pace your learning. In the days following the release of this video, expect to see new resources being released. An updated version of the testnet which simplifies the contract deployment process will be released this month, September 2018. A Blockchain Ardor written publication will be launching on the Ardor Medium page. And last, a new Ardor wiki is currently under development with a target release in Q4 2018. With all of that in mind, let's get started with this special edition of Blockchain Ardor.
Hi guys, so I'm here at the Donahue University for the hackathon, and during this hackathon we're actually launching one of the most interesting features that we developed for Ardor this year that we call the lightweight contracts. I'd like to explain, I've wrote a lot about it on Medium already. There's a lot of theory, but I know many people like to actually understand in video. So I'll try to really describe the simple step you need to take in order to use this feature. Because one of our design goals for this feature is simplicity. I mean, the lightweight contract does not provide you any ability that did not exist in Ardor before. It just takes everything and mesh it up into a framework that you can easily use without a lot of setup, without figuring out how to bootstrap APIs and things like that. All you need to do is be able to have some basic knowledge of Java and basic understanding of the Ardor API, and you're off to go. We really tried to make it very simple to developers to start working with our platform, because we know you have very little attention span, and we know you're busy, and we know you just want to get things done, and you don't want to mess up with the infrastructure and so on. So all you need in order to start with the Ardor contracts is, first of all, you have to install Ardor. Okay, you have to install Java. We recommend that you install the IntelliJ IDE Community Edition. It's one of the most popular Java IDEs, and the Community Edition is free and you can use it. So once you install Ardor, all you need to do is, of course, you need to start a node. You should have an up-to-date copy of the testnet database. Nothing new here. Once you install, the project itself comes with, the installation itself comes with a predefined IntelliJ project. All you need to do is open IntelliJ, do a file open, and open the Ardor installation folder as your project. If your Ardor installation project is not is read-only, like if you install on Windows to see program files, then just copy it first to your user directory and then open it inside IntelliJ. Okay? What you'll get is a fully functional project that includes about 10 sample contracts that we provided for you that you can use as reference. And these contracts are generally very simple, and you learn from them the main concept that some of them I will talk about. Some of them are documented in the body of the contract, and we intend to make it more documented and simpler. But you know, we will improve this iteratively and also based on your feedback. So you open the project. observes the source file of the contracts, observes the source code of the unit tests of the contracts. Okay, for each contract we develop, we also develop a unit test, and we recommend that you do the same, because this immensely increases the security of your code and reduces the chance that you make some mistakes that will cause your contract to malfunction or something like this. So I recommend that you start by just experimenting with the sample contracts that we provided. For example, start with the hello world contract or the random payment contract, which are really trivial to understand, and then work your way into more complex use cases. And of course, when you eventually implement your solution, you can use the existing sample contract as reference. So once you're so out of the box in the project, you can just compile the contracts. They should compile. All the unit tests should run using a launcher that we call a ContractSuiteRunner. So you can just run it from inside IntelliJ and it will work. Then to actually use the contracts and deploy them to the blockchain, we have a utility called Contract Manager. The Contract Manager, since the deployment of contract is a two-step process, and we wanted to make it very simple for you, we created this utility which simply deploys a contract to the blockchain. When you will see the contract deployed, you'll actually see two transactions. One is the class file of the contract itself deployed as cloud data transaction, and another transaction that we call a contract reference, which provides the access point to the contract. So it basically provides a unique name for the contract, contract setup, optional contract setup parameters if your contracts need it, and a reference to the actual contract transaction stored in the blockchain. So the contract manager, with one command where you specify the class file and the name of the class file, it will upload it to the blockchain. You'll need to wait for the next block, and then your contract is available. Once your contract is in the blockchain, how do you trigger it? The contract itself is executed by an add-on that we call the ContractRunner. So there are basically two prerequisites to execute the contracts. Once you need to configure a usable contract runner. Okay, there are a few properties in the NXT properties that you need to define. It's documented in the wiki as usual. So basically there are 4 ways to trigger contracts. The first, and I predict would be the most popular way, is to send the contract a trigger transaction. Trigger transaction for the contract is a transaction with a special attached message that will trigger the contract. Once you have the contract runner running and you want to trigger a contract, of course, it's not only you, anyone can trigger this contract, is to send a transaction, submit a transaction with attachment that triggers this contract. The contract runner will run and constantly monitor the blockchain for this type of trigger transactions. Once it identifies a trigger transaction, it loads the contract from the blockchain, invokes it, passes it any setup parameters from the contract reference, any invocation parameters specified as part of the message attachment, and then the contract executes. Like, what does it mean executes? For example, in the hello world contract, it will receive a message from an account and will send an answer, will send a greeting back to the same account as a message transaction. The random payment contracts, for example, will receive random payment, will receive a payment and the trigger message from another account. It will then create a random number between 0 and 2, multiply the amount sent, and will send back this amount minus transaction fee back to the sender amount. So it's kind of a way to demonstrate randomization of things on the blockchain, which is very useful for games and gambling and simulations. Another type of trigger is what we call a block trigger. So if your contract is designed to be block triggered, it will be simply, the code in it will simply run whenever a new block is received by the node running the contract runner. Another option is to trigger a contract using a voucher. This is very good for in case whoever needs to activate the contract does not already have tokens. Like think about a faucet that you want to fund Ignis to a new account that does not have Ignis, or Ardor to a new account that does not have Ardor. You cannot expect them to submit a triggered transaction because they don't have tokens to pay the transaction fee. So trigger by voucher is a third option. And another option that is, I view it more as a debugging option, is to trigger the contract using an API. Okay, in this case, the contract will not actually submit transactions, it will just show you, it will just simulate the work of the contract and will show you what transactions it is about to submit. Now, what's good about our contracts is that we don't care if you have a bug and the contract enters an infinite loop or runs out of memory or causes a stack overflow. The worst thing that will happen is that your node will crash and that you need to restart, fix the contract and restart it. It's not a systematic risk to all the network to have a loop. And because of that, we don't need to meter the execution of the contract. You can simply program in Java, invoke the normal APIs and so on. We provide you, in order to make it easier for you, you always receive a context object. Every contract invocation receives a context object which provides you all the services that the blockchain provides. It's kind of the interface between your contract and the blockchain. So that we never want you to go directly to the blockchain because we don't want your contract to rely on an interface that might change in the future. Whatever you do through the context object is guaranteed to be backward compatible in the future. Then whenever you want to, another option you always have is to query the blockchain using existing APIs. And of course, when you want to submit a transaction, then the context provides you a create transaction method to which you send the transaction parameters. It also helps you with all the fee calculations, which is always challenging, so that by default it will provide you the best bundling fee. Contracts are stateless. What do I mean by contracts are stateless? In most contract development framework, the contract inside, for example, if you have a contract to maintain token balances, the token balances are part of the contract. And this causes a lot of problems. For example, if you have to deploy a new version of the contract, you somehow need to migrate the balances from the previous version. We don't have this problem because the way you should design your contracts is that they should never store any information. They receive all the information they need from the trigger transaction, do some processing, either using the context or using the APIs, and submit some transactions in order to store the result of the calculation. The contract itself should never hold any data by itself. one great thing that it allows us to do is to run many contracts in parallel. Because there is no state, there is no problem to parallelize the execution of contract. Another good thing that because the contract does not have any state, it's very easy to change versions for the contract. Because of the design that we have, the contract is stored in cloud data, and there is a contract reference. When you let's say you want to upgrade your contract because you found a bug or you want to add functionality, you simply deploy a new version of the contract, and then you change the reference that you had to the previous version of the contract to the new version. As soon as your contract reference updates, every new contract runner will immediately activate the new contract instead of the old contract, and again, no migration is necessary. Okay. Then again, because contracts are simply Java classes built on Java sources, if you, for example, want to integrate with a Java library, all you need to do is add the jar file to the class path of the node runner. Remember, our contracts run on a single node. They are allowed to be used as oracles. They are allowed to integrate with external systems. They are not part of the consensus. I mean, there is no risk that one contract will bring one result and another will bring another result and the network will fork. So it's perfectly fine to program a contract that checks the exchange rate between Bitcoin and your favorite token. I mean, you'll have to trust this contract not to cheat, all right? But the basic functionality, all you need to do is program it in Java using any library that the data provider provides you. I recommend that you experiment with the examples we provide. You will see that many of them automate tasks which are somewhat difficult to do manually. Like, for example, the issue of funding account with Ardor when you don't have Ardor. So this is something that the contract takes care. It can take care of renewal of leasing, so that when your account leasing is about to expire, it will the contract will automatically lease your lease again. Essentially, everything you can do with the API, integrated with any external system to which you want to connect. Let's talk a little bit about the security guarantees of the lightweight contracts. By design, our contracts are not executed by every node, but by a single node or by a single node that executes a contract, and perhaps few other nodes that approve the transactions. This provides contracts are still Turing-complete. They can enter infinite loop or run out of memory or cause stack overflow, but it's no longer systematic risk to the whole network. So we don't have to meter the execution. We're just executing using a regular Java virtual machine. If the contract malfunctions in some way, the worst it can cause is for this single node until it's fixed and redeployed. However, there are few problems that we need to be aware of. When you when you trigger a contract with transaction, the contract processes the transaction and typically submits one transaction or more. We want to make sure that there is no issues in case, for example, the transaction that triggered the contract somehow expires and not included in the blockchain, or that the transaction that triggers the contract is included in the blockchain, but the transactions submitted by the contract are not included in the blockchain. So in order to guarantee against that, we are using some of the built-in features of Ardor. First of all, every transaction submitted by a contract as a result of a triggered transaction will use the trigger transaction as reference transaction. What it means that the transaction submitted by a contract will be included in a block only if the trigger transaction already made it into the blockchain. So there is no risk that the trigger transaction, for example, the transactions that fund the contract, expires or not included in the blockchain, and the transactions submitted by the contract are included in the blockchain. Then we need to protect against situation, for example, that a contract is triggered by a block, for example, but this block is on a fork that will later is later going to be rolled back and replaced by a better fork. So in order to in this case, we don't want the transaction submitted by the contract to be included on the blockchain, because when the switch to the better fork occurs, the contract will submit another transaction possibly. So it might double spend. So whenever a contract submits transactions, it uses an Ardor feature that we call the easy block. It actually specifies a block that must exist in the blockchain in order for the transaction submitted by the contract to be included on the blockchain. And this makes sure that if the blockchain switches to a better fork, any transactions submitted on the wrong fork are going to expire and not get included in the blockchain. Only after the switch to the better fork, the contract will have another chance to execute and submit legal transactions or transactions that make sense. Then there's the issue of the trust. Okay, when you run the contract on every node, then you don't need to trust any node. When you run the contract on a single node, then you need to trust whoever runs the contract runner not to cheat. Okay? So first of all, I have to admit that there is a trade-off here. By only executing on a single node, you get a lot of benefits, but you lose some of the trust. But in order to mitigate the risk, we have several fallback mechanisms. First of all, there is a mechanism to make sure that if someone provides you the Java source code of the contract, you can compare it to the class file deployed to the blockchain and make sure that the source code indeed corresponds one-to-one to this class file. But then there's the issue: how do you actually make sure that whoever executed the contract runner actually ran the class file that is stored in the blockchain, and not just run another malicious class file that somehow changed the result? Think, for example, about random games that is suddenly not random, but it's skewed towards the contract runner interests. So in order to protect against this, we actually allow other nodes to run the same contract with the same transaction, but in verification mode. In this case, you can run with the exact same contract with the same parameters, and you should get the exact same output. And you can double check. If you did not get the exact same output, then you can raise a flag or announce that this contract is possibly malicious. But this way you still cannot undo what the contract does. However, we can have a better layer of security by using what we call account control. The idea with account control is that the contract runner can submit transactions, but these transactions are not automatically, they are included in the blockchain, but they are not automatically applied. Instead, someone needs to approve them. So approval can be manual. Someone can check that this makes sense and then approve manually, but of course we want to do it automatically. So you can actually another node can run the contract runner in approval mode. So the contract account is under account control. The account controlling the contract account runs its own contract runner, and if it reaches the exact same results as the contract runner itself, then it submits approval transaction and makes sure that that the transaction is included in the blockchain. If not, this transaction will still be included in the blockchain, but it will never, its usage will never affect the blockchain. So it will have no effect. Okay, so this gives us relatively good protection against malicious contract runner. Okay, using account control and another contract runner. Then there is the issue that since the contract is not executed by all nodes, how can we promise that it's executed at all? Maybe the contract runner will just want to receive the funds from the trigger transaction, never execute the contract and deliver its promise. So until recently we had no good solution for this, but we recently came up with a clever mechanism based on secret sharing between the user who triggers the contract and the transaction submitted by the contract. So only when a secret is revealed, then both of them will be included in the blockchain. If the secret is not revealed, then both of them will not be applied. Okay, so as you can see, the lightweight contracts get a lot of usability improvements by only being run by a single node. You can program Oracle contracts that interface with any external system. You don't have to worry about gas while you execute the contract. The contract execution itself is free. You only pay transaction fees on transactions submitted. The contract does not maintain any state. So when you deploy a new version, you don't need to do any migration of the previous balances or state of the contract to the new contract. Okay, so just to finalize, the contract runner is essentially an automation layer on top of the existing Ardor APIs, which provides you good security with good usability and allows you to further customize the Ardor blockchain. Please try our contracts. They are available on testnet. All you need to do is install the software and follow a relatively simple tutorial. And let us know how it goes. If there are problems, we are on all the support channels, Slack channels, Telegram, and so on. So thank you for now, and let me know how things go.